Hi guys, it's Mr. Ross again. Today I'm going to go over the zero exponent rule and the negative exponent rule. This is part 2 of our lessons on exponents. Again, this is a review from Algebra 1, but as I stated in the earlier video, you really cannot be successful in Algebra 2 without reviewing the concepts, the basic foundations from Algebra 1. So many of these lessons hopefully will be a review for you until we get to the new material. All right, so we're gonna go ahead and start. I'm gonna go ahead and minimize my video here. All right, so as you can see, anything raised to the 0 power is a 1. All right, do not confuse this with the power of 1. All right, if something is raised to the power of 1, then it stays the same. But if something is raised to the power of 0, all right, then the power of 0, then that's going to be a 1. All right, so straightforward. Anything raised to the 0 power, so that is simply 1. All right, and you can try this on your calculator too. If you do 7 and you do that little caret key, looks like an upside down V, and you press 0, you will also get 1. So if you want to try that out on your calculator, go ahead. All right, now this one has a negative 7. Guess what? Same exact answer. It has the parentheses around it. All right, if it has the parentheses around it, then that 0 applies to what's inside. So that means it's negative 7 to the 1 inside with a 0, and then you take that 0 and you multiply it by the 1. All right, any power, all right, multiplied by 0 would mean it's going to turn into a 0. So then that's going to be negative 7 to the 0, which of course is a 1. All right. Now this one's a little trickier, and this one kind of trips people up. Now in this one, it doesn't have parentheses. So if it doesn't have parentheses, then this 0 only applies to the 7. It does not apply to this negative sign. So in that particular case, it's a negative because the negative has nothing to do with that 0. And then 7 to the 0 is 1. So my answer ends up being a negative 1. Okay. And if you're looking for a more detailed explanation here, you can kind of see it here. The 7 is only affected by the exponent, not the negative 1. All right, so you can think of it as like a negative 1 out in front. All right, but it doesn't affect the 7. The 7 is affected by the 0. 7 to the 0 power is a 1. So then we end up with 1 times negative 1, which of course is going to give us the negative 1. All right. So again, the 0 only affects what it's right beside because it doesn't have the parentheses around the negative sign. So we end up with a negative 1. So that one can be a little tricky. All right, now on this one, same thing that's going on this one. This 5 has an exponent of a 1. Right? This 0 right here, this 0 does not affect the 5. It only affects the x. The only way that that 0 would affect the 5 is if both the 5 and the x were inside of parentheses, which they are not. So on this particular one, it's only the x that's affected. So x to the 0 is the 1, and the 5 stays the same. So 5 times 1 is what gives me the 5. So I know it seems kind of like a technicality, but those are some tricky problems for some students. All right, now this one looks like it's going to be just terrible to solve because it's massive over here on the right. But you have to remember, if it has parentheses, all right, and it's got an exponent on the outside, and that exponent applies to everything on the inside. So even this 6, which remember, if it doesn't have an exponent, it's an understood 1, everything's going to get multiplied by that 0. And as you know, any number times 0 will give us a 0. So everything inside is going to turn into a power of 0. Because every one of those numbers, 1, 2, 3, and 4, are all multiplied by 0. And then, of course, anything to the power of 0 is a 1. So we just have 1 times 1 times 1 times 1, which, of course, obviously is 1. And so basically, we just got rid of half the problem is what happened. We don't even need this part anymore. It's gone. This part just turned into the number 1. And 1 times any number will stay the same. So we've effectively deleted half the problem. Now, we still have to deal with the other side. All right, this is the breakdown. Then we still have to deal with the other side. And you can see here that these two have an understood power of 1. that was not listed, and they're added right here in red. Okay, so in order to get to our answer, you're going to take this 4, using our power rule, we have to multiply out those numbers. So it's going to be 3 to the 4th, it's going to be x to the 4th, and it's going to be y to the 8. And remember, this part right here, all of this turns into 1. So that's why we don't really even need the 1 anymore. As you can see here, the only thing left to do is to simplify what 3 to the 4th is. All right, so 3 to the 4th is 3 times 3 times 3 times 3. Again, you can use your calculator and do this, 3 exponent key 4, or you can do 3 times 3, 9, 9 times 3, 27, 27 times 3, and that's going to give you 81. So it'll be 81 x to the 4th, y to the 8th. Can't forget about your x and y up there. And again, this is just going to keep breaking it down for you. I already showed you to simplify that one side equals 1. And of course, that's how we get our 81. And again, if you need to, you can go back and review these notes. They're going to be saved to Canvas, or you can go back and watch the video again. So, all right, the second thing I want to talk about today is the negative exponent rule. There are negative exponents. They do not necessarily mean the answer is going to be negative. It simply means that you cannot have a negative exponent in your final answer. So if you start off with a negative exponent, then your final answer cannot have a negative exponent. The only thing you're allowed to list would be positive exponents. So that's going to be the big one we got to watch out for. All right. The other thing that you probably remember is when you were doing this in Algebra 1, the negative exponents typically went to the denominator or the bottom of the fraction. All right, and the only reason why they would ever move to the top is if they were already on the bottom or the denominator, then they would move to the top or the numerator, okay? But anytime you move a negative exponent, it becomes a positive exponent. So let's try this out. All right, so in this particular problem, we got quite a few negative exponents. We got a -4, we got a -9, and we got a -6. Do not confuse the negative exponent with negative numbers. That 5 is a negative. It does not have a negative exponent. In fact, the exponent is actually a 1. All right, so here's what we're going to do. We're going to take all the negative exponents and we're going to move them to the denominator, all right, and we're going to make them a positive exponent. All right, you may also notice that we have some negative exponents already in the denominator. So we're going to have to move them as well, and they're going to end up moving to the top. All right, so you can see here I've added the 1. First step. All right, second step is we're going to move any negative exponents, all right, and we're going to move them to the bottom. All right, so we're going to start off with the top. Y to the -4 is going to move to the bottom over here as a positive exponent. But you're going to notice that still leaves 2 negative exponents right here on the denominator. Well, normally we move them to the bottom. Well, in this particular case, they're already there. So they can't move to the bottom again or the denominator again. So if they can't move to the denominator, then you have to move to the numerator. So these 2 negative exponents can't go anywhere but up since they're already on the bottom. So those 2 show up here in our numerator. So basically, if it has a negative exponent, it has to trade spots. Typically, it's going to go to the denominator or the bottom, but in some cases, if it's already located there, it has to move to the top. Okay? So I'll go back to where I have some space here and I'll show you. All right, again, what effectively we did is we kept these 2 here because they did not have a negative exponent. But this y value right here was a negative exponent, so it went to the bottom. Well, that takes care of that one, and that one. So we got 3 down. Now we look over here, that T3 is not a negative exponent, so it gets to stay where it's at. All right, this is a negative exponent, so it moves to the top. And this one is also a negative exponent, so it also moves to the top. So it's a lot of trading places is basically what's going on. All right, so let me catch back up to the notes over here. All right, and you can see here how we ended up with our answer, -5 x squared w6 z9 t3 over y4. All right, I cannot combine these guys together. And the reason why I can't combine any of those together is because none of their bases match. They all have a different base. One's an X, one's a W, a Z, a T, and a Y. Okay? That's a good practice problem right there. All right, let's take a look at this one. All right, there are basically 1, 2, 3 parts to this one. Which one of those is a negative exponent? Well, the only negative exponent is this one, and that's your X value. So we have a -4, all right? We have a Y, none of them are negative, so they stay where they're at. But what do we do with negative exponents? Well, typically we move them to the denominator. You'll notice that this was not set up as a fraction. So in this particular case, you'll have to make it a fraction and you'll have to put the X squared in the denominator or the bottom. Okay, again, you will notice that the ones that did not have an exponent have an exponent of 1 listed, and you only move the negative exponents. You will notice that the X squared ended up on the bottom. Now, if you check the final solution here, you will notice that we dropped the ones. The ones are not necessary, right, if you're not going to change them. And so since I couldn't add the -4 and the Y together, right, I don't need the ones anymore, so I just dropped them for my final answer. All right, what about this one? 4 to the -3rd. Again, you cannot have a negative exponent. Where do negative exponents go? We move them to the bottom. If there's not a bottom, then you have to create a fraction and we move it to the bottom. Again, please note, every time you move a negative exponent, it becomes a positive exponent. So 4 to the -3rd becomes 4 to the 3rd. Now you cannot have a fraction without a numerator. All right, so we have to add the number 1 to the numerator. Again, you cannot have a fraction without a numerator. All right, and that's what happens here. It doesn't look right, it looks incomplete. So you just have to make sure you add the 1 there. All right, and the 1 will make it complete. Now, if you're wondering where they came up with the 64 number from, again, exponents mean how many numbers there are. So this means 4 will be there 3 times. 4 times 4 is 16. 16 times 4 is how we get the 64 number. So we get 1/64. All right, this should be the last one. All right, I have a -2 to the -6. Okay, first things first is the negative is inside the parentheses. That's important. So it means that the negative is going to follow us since it's inside the parentheses. The other thing is this is a -6. You cannot have a negative exponent in your final answer. So this -2 is going to have to move to the bottom and the -6 becomes a +6. Again, you cannot have a negative exponent. That means you're typically going to move it to the denominator. If you do not have a fraction, you're going to have to set up a fraction. And we cannot leave it blank on top. So we have to add the number 1 on top. All right, at this point, we have a -2 to the 6th power. Now, I'll walk you through the notes here. You can see here, we've moved it to the bottom. All right, how did they get the number 64? Again, it means -2 6 times. When you multiply out a negative base like -2 6 times, an even number of times, it should turn into a positive. All right, so for example, you got a negative times a negative, that's a positive. A positive times a negative is now a negative. A negative times another negative is a positive. All right, that positive times a negative makes it a negative, and then a negative times a negative is how we end up with a +64. 2 times 2 times 2 times 2 times 2 times 2 is how you get 64. If you were to do that on your calculator, you would have to put the negative inside of parentheses with the upside down V, the caret key, and then raise it to the 6th power, and you also would get this answer. It would work. So if you need some help with your scientific calculator, just reach out to me and I can set up a Zoom session for you. But that's how you would do it. All right, the remaining problems, I'm gonna save those for the next lesson. All right, I'll go over that tomorrow. It's basically just a continuation. It'll just be part 3 of these notes. They just get a little more challenging, a few more steps. So I'm going to stop there. Again, if you guys have questions, please reach out to me through Canvas, through email, and I'll get back to you as quickly as I can. Also check on Canvas. I'm going to post my office hours. I'll offer them up a couple days a week. That way, if you guys need to Zoom or something, you guys can join as an open Zoom session, or I can open up a Zoom session for you during the school day. But just let me know. Remember, communication is going to be key for this virtual learning. All right. I'm going to stop it there. Thank you guys for watching this video. And please let me know if you have any questions.